Hello everyone, I'm a tutor with Applats and we are going to learn about SQL. Before starting with SQL, it is necessary that we understand some basics of databases, and today's lecture is going to be an overview for the same. For today's lecture, we have planned we have planned to learn what is a database, the purpose of database, different types that are available for data in databases, so that different databases are used in different domains. So we will learn more about it. Things you can do with RDBMS. Now, RDBMS is a relational database management system. You will learn more about this in the later part of the course. We'll learn about the data models that are available and some basic terminologies before we start with SQL. So what is a database? Database is a collection of organized data, information, and records. It contains the information about one enterprise. It maintains any information that may be necessary to the decision-making process involved in the management of that organization. Now, what does that mean is relate database with an office. Office is just similar to a database. Office is a storage. An office contains various files, records, information of different clients. Similarly, a database also is a collection of data which is organized, which in case of office might not be an organized way, and information and records. The only difference between both of them is the structural way of storing data, and that office is a structural storage while database is a software. Now, there are few advantages of DBMS. Basic ones are the advantages that are provided by DBMS are reduced redundancy. Now, what do you mean by reduced redundancy? It simply means that database redundancy is just duplication of data. Non-database systems maintain separate copy of data for each application. So what happens in an office is that when you have a record of one client in one file, suppose if that particular client has reordered something else, so you need to maintain another record for that same client with all the details again refilled. This is simply duplication of data. That is what we are referring to as redundancy. In database, what happens is that we are keeping a collection of all the tables together, wherein one table is particularly dedicated to storing the information of clients. Another table will be storing the information of orders. This way, the database helps to reduce the redundancy. That means it avoids duplication of data, giving us better user experience. Now, second advantage, that is controlled data inconsistency. What exactly does this mean is that when the redundancy is not controlled, there may be occasions on which two entries about the same data do not agree. That is, one of them stores updated information and the other does not. At such times, the database is said to be inconsistent. Now, very good example for this would be in an office. Let's say for one client, we have two different files maintained. Suppose the address of that particular client has been updated. The official has updated only one file for that client, while the other file still shows the old address. Now here there is clearly a mismatch of address of that one client. So this is what is inconsistency, which is taken care of in a database because there is something called as cascading. So when we are updating one record of that one client, everywhere it is reflected at the very same time. There are some rules to do it, which we will learn more later in the course. But for now, this is how we can control data inconsistency if we are using a database. Next advantage of a database is a sharing of data, that is shared data. Now, what does this mean is that individual piece of data in the database may be shared among several different users, in the sense that each of those users may have access to the same piece of data and each of them may use it for different purposes. So now what happens here is that suppose we are working in a bank organization. Now, if I am updating some record from one branch of that bank that this particular user has deposited X amount, now this has to be updated in all my branches of that same bank because my account for that one particular customer is just one. And so data should also be updated. That's where shared data comes into the scenario, wherein I am sharing some data, I'm updating some data at one location, but the same is being reflected everywhere because it is accessible from anywhere. That really does not happen in case of office storage. Because what happens in office storage is that if I want to share some data, if I have updated some data, I'm not sure whether it is consistent or not. Again, this will cause data inconsistency. So that is a very big advantage of database. Next, what we have is standardized data. Now, the DBMS can ensure that all the data that is stored centrally follow the applicable standards. There may be certain standards laid by the company or the organization using that particular database. Similarly, there may be national or international standards. Standardizing stored data formats is particularly desired as an aid to data interchange or migration between systems. Now, what exactly the standardized data mean that there are some rules that we need to follow while storing data. That is not the case while we are storing data in an office. When we are physically storing some data, the company itself approves of some particular format. There could be a possibility that one client having two different orders have two different forms of or storage of data. Both of them are they're not inconsistent, but they both have different formats of storage. But that generally is not the case with database. There is only one form, there is one rule, there is one standard followed, due to which it becomes very easy for the other user to read data. And hence standardization is very important. Next, we are talking about is the secure data, security. Now, when we're talking about security, when we're talking about data, it is more important that we concentrate on its security as well. Because when it comes to organization, let's say a company and some MNC, they have some data stored. Obviously, that data should not be leaked. So it is very much important that we take care of data security. For that, we definitely have some authorization or accesses which can be controlled by the admin for database. But that is not the case with an office. If your office is a storage of data, in that case, there is a possibility that there might be some data loss, there might be some file theft or some issues with that. So security is comparatively less in that area. But when we are talking about a database management system, it ensures data security and privacy by ensuring that the only means of access is through proper channel, and also by carrying out authorization checks, which might not happen in an office. Whenever access to sensitive data is attempted. So whenever you see that there is some access to sensitive data, there will always be some authorization checks being performed. Now, what does this data security term exactly refers to? Data security refers to protection of data against accidental or intentional disclosure to unauthorized persons or unauthorized modifications or destructions. Definitely, when I am running an organization or if I am running a company, I would not want my data should be shared accidentally or intentionally to any other party, to any other unauthorized party. And for that, we need to secure our data. Next is privacy of data. Now, security and privacy are very different terms. So data security was all about securing our data against unauthorized access or modification or destructions. In case of privacy, it refers to the rights of individuals and organizations to determine for themselves when, how, and what extent information about them is to be transmitted to the others. Now here, privacy means that suppose if I want to share my data with some unauthorized person, then there is a limit to it, that only this part can be shared with them. Above that, once that limit is breached, we cannot share any more data, because that actually breaches the privacy and the confidentiality of data. So security is a very good advantage of DBM database, because we have different softwares, we have different methods to secure our data, which might not be the case in case of an office or a physical storage. Next, we are talking about integration. So what exactly does integrated data mean? So when a database contains data employed by many different users, it is important that association between data items should not be destroyed. Hardware failures and various types of accidents will occur occasionally. The storage of data, its updation, insertion procedures defined by the database are such that the system can easily recover from these circumstances without harm to the data. Now, this is the most important point, the integrated data. Suppose, for example, in your office, there is some leakage, some ceiling leakage, okay, due to which some files were destroyed. Now, some information is lost, which is not possible to recover because those files were pen and paper written, or maybe ink written or ink printed. But in that cases, the data will be lost. Retrieving or recovering from that phase becomes very difficult. But in case of databases, suppose if there is some hardware failure or there is some software failure, there are rollbacks possible. So let's say we are working in a bank organization. I started with a transaction, but due to hardware failure, I could not complete it. Now what that system will do is it will roll back my transaction. That is, if I was supposed to deposit 200 rupees, I was in the middle of the transaction wherein my 200 rupees was getting added to my previous balance. But due to hardware failure, that was not possible. So what exactly the system did was it rolled back, and now my account balance is same as it was before. Or probably it might commit it after that failure is recovered. But there is no midway that I have lost some data. There is always a fallback strategy available in case of database, which is very much necessary in the current pace of life. Now, next that we are going to talk about is the purpose of database. Now, I guess advantages has already covered that why exactly do we need to use a database. So database is the information that a person needs in his personal, business, social life. The power and purpose of information is not only in collecting and finding them, but more importantly in using them. So consider a company which has a lot of data. Any gaming company, it has a lot of data. To improve more on their game, they will have to check the historical data. Now, so they have collected the data, they have found the data. Now, how can they make use of it? For which we need past records to be available within one view. But in case of file structure, you must have seen, if you want to know, if you want to analyze data, it becomes very tedious. You have to read, you have to write, you have to search, manipulate, update the records, create a view so that everything is available in one section itself, which is a very difficult task, very tedious to do. But in case of database, there are simple queries that which we can use and probably manipulate our data and create a view of that, due to which the reading becomes easy, analyzing becomes easy. So that is the main purpose of databases. Even in growth of organization, database is very useful. Moving to next, there are two different kinds of database that we have. One is the structured database, other one is the free form database. Now, what exactly is a structured database? It is called the structured data in which a record or a file of information is arranged in uniform format. Now let's say if I have now we are not talking about database or file structure, just talking about the structure, how structural your data is being stored. Let's say in an office, there are some random files with some random records in it. This is a very unstructured way because I don't know when I want to search for a client, which file to exactly search for. But my every file has a name on it that this file is dedicated to this client. I exactly know how to search for it. That's where the structural part comes into the picture. Now, these databases are usually storage of information with similar entries, such as a list of persons born in a country, a medical database of patients' data, an inventory database of a company, and many others. So while I was explaining you that what is a database, I mentioned that it is generally created for one enterprise. That is what we are talking about. So when I talk about a company, a database is completely dedicated to the data of that company. You will never see that one database is storing data for two different companies. That will never happen. That's where the root of structure starts. So that is structured database. Now coming to free form database. Now this is a loose collection of information, such as those you will find on Google or on your World Wide Web, whatever. A collection of your documents in the computer made from several programs can be considered as free-form databases. So you can refer to free-form database as more of unstructured, but In this case, we are not very much concerned about finding that, because there is always an option of searching, which is much better and much faster than the normal database. So in case of Google as well, if you search for basics of database, you get 10 links available. But what is the reason behind is that you get the 10 links which are very much relevant to your search engine. That exactly is free form database. And those 10 links can be from any different companies or any different websites or any different portals. That does not matter. So this is all scattered, but still structured. So that is free form database. Now in types of database, now we just learned about kinds of databases. Now we are going to learn about types of databases. There are two different types of databases. One is operational, the other one is analytical. What is happening in operational is that it is a dynamic database that is used by any organization in its day-to-day operation. They are used to collect data, maintain, modify, and delete. They are also known as transactional database. Now let me give you an example. Consider a bank organization as an example for this particular slide. Here, this is an operational database, because what we are doing exactly there is every day, whoever is creating an account, we are updating our database. We are collecting data. Let's say someone is depositing some amount into his own account. We are modifying some data. Let's say someone has closed his account with the bank. Then he is trying to delete that data. So this becomes operational database where your day-to-day activities are being tracked. Now coming to the other part, that is analytical database. Here what we are looking for is, it is a static database where data is rarely modified. Analytical database generally you will see in big data domain, where there is a huge data available. You will never see that that data is being modified or that data is never being updated. Because what happens is that it is just a historical storage of all your data, and it is generally used for making long-term projections and analysis. So what is happening is that, consider the gaming company example, wherein you are just storing every day's data, and now the database has become static. You have some old data which you cannot modify, because those are like records we have achieved from our users. You cannot modify that data, but definitely you can learn the behavior of the users which we have tracked in our analytical database, and based on that you can predict the future. This is the analysis part. So that becomes an analytical database. You can any day transform your operational database to analytical database, but there comes some certain negative aspect to it, because there are some restrictions to the storage of data. The data, if it becomes more heavy, then operational database might not be able to fetch results in a faster manner, for which you would need some other types of tools for analytical. So in analytical, you would see that we have AWS, we have Hive, we have EMR, where you can analyze the data, huge data. But in case of operational databases, you can use MySQL or some SQL platform, some SQL server, because there we are generally concerned about maintaining the day-to-day operations. Moving to next is the RDBMS. So right now we all talked about databases. Database is nothing but part of RDBMS. What is RDBMS? Relational Database Management System, wherein relational data is being managed by a system. That's what is an RDBMS. So basically what it does is creates a database. It stores some information. Whatever information is being stored, we can retrieve that. Now we have to manage that information so that none of them are leaked, or probably we have secured our information. So all that part is covered in information management. Next is information analysis. That is, whatever data we have, we probably want to do a little analysis on that for future prediction. And next, what we have is printing and sharing of information. Obviously, once we have created our view, we need to share our information with, let's say, the other levels of organization. So that's where it comes from. Next, we are going to talk about the basic flow. Now, what exactly happens is that relational databases is the root. So there is one database that is dedicated to one enterprise. Now in that one database, you will have n number of schemas based on number of users who are having access to that database. So you will have individual schemas. So let's say employee A is part of that particular organization and wants to have an access to that relational database. So that one schema will be created in his name. Similarly, there would be many others. Now tables are nothing but the information, the actual data that is being stored inside a schema. So this will always be the flow, and similar structure we would be following about SQL, its basic queries and all. Moving to next. Now, we have talked a lot about database, but it is really important that you know your data. And to know your data, it is important to understand what is data. So basically, it is a number or value found and stored in the database. Data is static because it remains the same until it is modified by a process. So just as to inform, so Applats is one information, it is one data. Whatever Applats is offering as a course to you, that is data. Now, here the data for Applats is not static because Applats is just improving day by updating more information, adding more courses available to you. So this data is dynamic. It is being modified every day for better user experience. But there are few cases wherein data is static, and that is static because it has never changed. Let's say there was some XYZ company which had started long back, and now there are no operations being performed on that. So my data will remain untouched, my data will remain unchanged. So that is the time when data becomes static. Coming to information, it is a data that has been processed, thereby making it relevant and meaningful to the person viewing it. Information is dynamic because it changes relative to the data stored in the database and could be processed in many ways. Now, this was a little complex. I will simplify the definition for you. Data was basically some raw kind of information that we had. Suppose this is, tell me the name of first 5 customers. This is information. The name of that customer is ABC. This is data. So there is a very thin line between data and information. Data is the exact value. Information is the meaning of that value. Next is null handling. These are some common terminologies that you will come across when you are using SQL. But before we start, generally that there is a perception that null values are generally referred to as 0 in the database, but that is not the case. Null means we don't know. So whenever you see that there is some null value against that particular client, so it does not mean that it was 0 or it is some blank value. It's just that we don't know. So what happens, consider an example for bank. In that, if you see that the mobile number against one particular client is null, now that does not mean that it is 0, or that does not mean that the user does not have a mobile number. It just means that we don't know the mobile number, or probably it is just not being updated in our database. That's the basic interpretation of null. And why null is very much important to understand is whenever you come across some queries, some outputs, if you try to run them, we have to understand the equalities of null values. Null compared with, null first of all cannot be compared with anything. Null and anything is null. So null cannot be compared to anything. Now next we'll talk about table. So we talked about relational databases, we talked about schemas, we also had table. Table is the main source where all your data is going to be stored. Now there is a small example that I have attached in the slide, you can refer to that. To make you more familiar with the jargons of SQL, table is also called as relation. Okay, why relation? We will understand more in the next lecture when we will talk about entity relationship diagram. That's where you'll understand that why it is called a relation. Next we have, as you can see, this is one table with 3 columns: customer ID, customer name, status. Okay, now when I say that these are columns, that is a very layman language. But in terms of SQL, those are also referred to as fields or attributes. So customer ID is a field, customer name is a field, status is a field, or you can say these are attributes. Now, similarly, we are defining columns. We also have rows in our database, as in this customer ID 1 with the customer name Google and active status. This is one row. Now in database, we don't refer to as row. There are two different terminologies for it. One is tuple and the other one is the record. So basically, more often in SQL, you will hear there are n number of tuples or records or rows with n number of fields or columns or attributes. And how to find a degree of a table. Degree of a table is basically the number of columns. So degree of this particular table is 3. Now to define it in a very layman term, it is the main structure in the relational database. Table defines the structure of the database. It is composed of attributes, that is fields, columns, and domain. Domain, that means records, rows, or tuple. A table must almost always represents a subject that can be an object, person, place, or thing, or an event. Similarly, here in this example, we can see that this table is dedicated to customers. So it has all customers data. Similarly, we will have n number of tables that is also related to customers, but it is storing some other information of that customer. So these are tables. Next, as I've already explained to you, what is a record? A record is nothing but a tuple, nothing but a row, or just, it is basically referring to a specific person, place, thing, or an event. So as we had seen in our previous example, or even here, this particular row, this row is dedicated to Google. This row is dedicated to Amazon of our customer. This row is dedicated to Apple as our customer. So it is referring to some specific person, place, thing, or an event. Now this is particularly referring to a person, it is referring to a company, one single company. And there is some status here, which we are not sure. It is probably showing that if this company is currently active with us or not. Now it pertains to structure in the database table, representing a unique instance of a subject. Moving to next, we have views. Now we learned about table, but there is something which I was also using very consistently, that was views, that we need to create some views on our table to understand that what exactly our database is holding. Now this view is also referred as a virtual table. Why virtual? Because what is happening is that it is not holding data on its own. In case of table, it was holding the data on its own. This table is like a house. The records, the data is like the family members living in that house. While in case of view, this is simply, we can refer to it as a virtual table wherein the data is being retrieved from the base table just for display purpose. It is only used for display purpose. You will never see that whenever you have updated some information in your base table, the view has to be rerun so that the data is updated in view as well. What happens is that if you're deleting or modifying a record, that particular table will be updated. But to update the view, you have to rerun that part of the query to update the view as well. So to give a formal definition for this, it is known as the virtual table, just as we discussed. It is called a virtual table since it does not hold data on its own. Rather, it gets the data from the table which it is based on. And since it comes from other table, it is composed of several fields coming from one or more data. So what is happening here in the view is that, what is the purpose of view? Now let's say there are two tables. One is the customer table and the other one is the salary table. Okay, these are two different tables. Now, if I want to see a common view of all the salary of all the customers, of all our employees, let's say. Okay, now this is possible only when I join these two tables and create a view. So that's where view comes into the picture, where we are able to see data at one place from different sources, from different data sources. Now a relationship. Now what is this? That it is basically, just as I told you, for example, that there was customer table and then there was this salary table. I want to see a view of both the customers having what number of salaries. So for this, there has to be some joining condition, or there has to be some connection between these two tables. As in, how will I understand that which salary exactly in table B refers to which employee in table A? So there has to be some connection medium between them. That's where we are talking about relationship. And that is the end. Next lecture, we will also discuss about the basics of SQL,